Okay, so I got in my laser diode. It's an 808 nanometer infrared diode capable of putting out about a watt continuous power. You have to have it heat sunk, and it should be in a focus tube. It comes with a glass lens. Now, this is a 9 millimeters in size, and I can't get one in the US, so I had to order it in China. So it won't be coming until March. I ordered a couple of them because I have a couple of these too. These are about 25 bucks a piece and up, but they are quite powerful. They put out a good solid class 4 laser, and I'll demonstrate what they are capable of, because I put together a circuit here, just a voltage regulator hooked to 4 D cells. It's an LM317 voltage regulator. You can make that, it's adjustable. I would have used maybe a 7805 or something, but the voltage has to be lower. These actually run on 2.2 volts or so, and they run on high current rather than higher voltage. You have to put out about 1.2 to 1.3 amps is the maximum that these will take, and that's what this circuit's capable of. This is the only information that I got on this at all, but as you can see, with the current goes up to 1.2 amps. Let's see, on this side the output wattage goes up to a little over 1 watt here. So, and that's what I've got it at, is a 1.2 amps or so. So I've got it maxed out. I can't run it continuously without a heat sink, but I can run it for 10-15 seconds, and it only takes a second to make paper smoke, at least with black colors. Now this is the LM17 circuit here. This came from National Semiconductors, just a typical circuit. This one happens to be an adjustable circuit from 1.2 volts all the way up to 25 volts. The only thing that you have to do is make sure that your input voltage is at least about 1.5 volts higher than your output voltage. And here they have R2. It's just the way they do this is a relationship between R1 and R2, and R2 here is a variable resistor. What I've done is I've modified it for my own circuit. This is putting out about 2.25 volts or so, and I just used it, instead of what they said, I used a 220 ohm resistor for R1, and for R2 a fixed 180 ohm resistor, and that's what makes the fixed voltage. And let me turn on the equipment here. I'll show you. I've got an ammeter on hooked to this, and I also have a voltmeter. So you can see, and I've got it all set with a push button switch. So make sure I'm not aimed at anything important here, because I don't want to burn anything. Okay, let's see. Yeah, I guess we can see these alright. I'll come in even a little closer here. And let's fire this thing up. The left one is amps, so it's about a little over an amp, and on the right is the voltage, and it's at a little over 2 volts. Okay, we didn't burn anything. Even with a 1 watt with the infrared laser, if you aim it at something, I had it aimed just at this. This is sandpaper, but I had it aimed at the part of the sandpaper that was not black. I've tried several different colors. If you can see these colors that I've tried it on, one's red, one's blue. The red and the blue the blue heats up some, but not enough to burn the paper. But that black magic marker here, right on the right, if I aim it at that, it'll make that paper smoke in less than a second. So let's do that. I don't want to destroy my optics on my camera, so I'm gonna put it in really close. The other thing too is you need a glass lens that's coming with a tube to focus it so the laser shoots out further. Otherwise, this laser spreads a little bit. And let's. But I want to cover that black up so that the infrared, even though you really can't see it, this is a $500 camera. I don't want to ruin the SLR pickup on it. Here we go. Look at that smoke. Whew. Okay, and you can see it burned right through the other side of it too. I've been playing with different parts of it. Now if you take it to black plastic, you can do the same thing with it. Make sure that you really should do this with safety glasses. I wouldn't encourage anybody to do this without safety glasses. Let's fire this up and watch this black plastic smoke really quickly. Yep, that is picking that up, but that'll burn right through that plastic in no time. You can hear that it's scratched it already, but in 5 to 7 seconds it'll burn a hole right through that plastic, and then on into the D cells. So that's my experiment, and next one I'm gonna do is with a DVD pickup, and I can get them up to at least 1/4 of a watt. I may try and push it up to 1/2 a watt, but that one you can actually see, and I can get the tubes for those in the US because they're a 5.6 millimeter package, a little less than 1/4 of an inch, where these are 9 millimeter. These are about 3/8 of an inch. So I'll be able to get those tubes quickly, the focus tubes. That's it. Thanks for watching.